Hello students, welcome back to the channel. Now this video onward we will discuss the further part of current electricity. So let's start. Now student, let's solve the sum based on whatever concept we have done till now. Find the potential difference. Potential difference is indicated by capital V. It is asked. Required to flow a current of 200 milliampere. Milliampere is not a SI unit. So first you have to convert it into ampere. So when you divide 200 with 1000, it gets converted into ampere. So it will be 0.2 ampere. Okay. In a wire of resistance 20 ohm. You have done Ohm's equation. V equals to IR. Now substitute the values. V is asked. I is your 0.2. Resistance 20. So it will be 4 volt. Got it? Now student, let's solve the next sum. An electric bulb draws 1.2 ampere current. So your I is 1.2 ampere. Ampere is already the SI unit. At 6 volt. So your potential difference is 6 volt. Find the resistance of the filament of the bulb while glowing. Same way you have to apply the Ohm's equation. V equals to IR. Now V is given 6. I 1.2 into R. So your resistance will be 6 upon 1.2. Put 1 0, point disappear, 12 ones are, 5s are 60. So your resistance will be 5 ohm. Now student, let's solve next sum. Calculate the current flowing through the wire. So current is asked. So I'll put question mark. Of resistance 5 ohm connected to the battery of potential difference 3 volt. Same way, take the Ohm's equation. V equals to IR and substitute the values. This is given 3. I is asked. Your R is 5. So your current will be 3 upon 5. That will be 0.6. Unit is ampere. So current will be 0.6 ampere. Understood, students? Now students, one more sum. Two wires of same material. Same material means their resistivity is same. And same length. Length is same. Have radii 1 millimeter and 2 millimeter respectively. So first radii is R1, 1 millimeter. So it will be 10 raised to minus 3 meter. Second radii 2 millimeter. So 2 into 10 raised to minus 3 meter. Compare their resistance. Now first we will compare their resistance. You know resistance is equals to rho L by A. Okay. Now A means area of cross section. So it will be pi r square. If first radius I am considering, so this will be formula. Same way for the second resistance, the formula will be rho L by pi r2 square because length is same. When I compare, means I have to find the ratio R1 by R2. Your R1 is rho L by pi r1 square. This is your rho L by pi r2 square. Now when you just cancel rho L and pi, then your r1 by r2 will be r2 square upon r1 square. Okay. So what is your r2? 2 into 10 raised to minus 3. 2 time I am writing because it is the square. And your r1 is 10 raised to minus 3. So when you cancel the common terms, 10 raised to minus 3 cancel. So what remains? 2 2s are 4 upon 1. So your r1 is to r2 is 4 is to 1. Now just concentrate, material is same. When material is same, so resistivity, that is specific resistance, will be same. So both values are same. So it will be 1 is to 1. Now student, just look at the sum. A given wire of resistance 1 ohm is stretched to its double. It is stretched to its double. So length will be double. What will be the new resistance? When length is double, the area, the wire will become the thinner one, and the area of cross section will be exactly half. So area will be half. Resistance will remain the same because same wire we are taking. So if I consider this as R1, then rho, if this is L, and this is area of cross section. Now this is given 1 ohm. So 1 will be equals to rho L by A. This is your value of rho L by A. Now my new length will be double. So new length will be double of the original one. And area of cross section will be reduced to half. The wire will become thinner as we have discussed earlier. So your R2 will be, rho will be same because material is same. Instead of length, I'll take L1. Area will be A1. Now according to relation, we see your L1 is 2L. And your A1 is half of A. Now just look at this. Either you can compare, or this rho L by A is your 1. So when you substitute that, rho 2 is as it is, rho L by A is 1. 1 by 2 when you take up, it will be 2 by 1. So when you multiply, it will be 4 ohm. So when the length is stretched double, area will be half, your new resistance will be 4 times of the original one. Now student, let's solve one more sum. What length of copper wire? Means length is asked. Of specific resistance 1.7 into 10 raised to minus 8 ohm meter. And the radius 1 millimeter. You know 1 millimeter means 10 raised to minus 3 meter. You have to divide by 1000. That's why you'll get 10 raised to minus 3. Is required so that the resistance is 1 ohm. You know resistance is equals to rho L by A. A means pi r square. So what is ours? L is ours. So R into pi r square upon rho will give you the value of L. Now let's substitute the values. Resistance is 1. Pi value you can take 3.14. Radius is 10 raised to minus 3. It is square. So I am taking 10 raised to minus 3 2 times. Rho is 1.7 into 10 raised to minus 8. You have to simplify this. Now, when you simplify this, just see 10 raised to minus 6 will get cancelled here. You will get minus 2. When you transfer here 3 up, 10 raised to minus 2 will become 10 raised to 2 upon 1.7. So, it will be 314 divided by 1.7. Put 1 0. Now divide. When you simplify this, you will get 184.69 meter. Understood? Students, thanks for watching this video. Hope you have understood whatever concept I have taken in this video. If you like the video, share and subscribe. Thank you.